Hey everyone, welcome to our new series on ordinary differential equations, or ODEs for short. I'm Bernard, and over the next few days, we'll dive into the fascinating world of ODEs with bite-sized, easy-to-understand videos. Let's get started. Imagine you have a car traveling down a road. The speed of the car is changing over time. An ordinary differential equation can describe this change in speed. You might be wondering, where do we use ODEs in real life? Well, they are everywhere. For example, in biology, ODEs can model the heartbeat rate. In physics, they describe how objects fall under gravity. And in ecology, they can predict population growth. Before we dive deeper, let's get familiar with some basic terminology. Derivative. This measures how a function changes as its input changes. Think of it as the rate of change or the slope of the function. Function. This is a mathematical expression that relates one quantity to another. For example, y equals f of x. Order of an ordinary differential equation. This is the highest derivative in the equation. If the highest derivative is the first derivative, it's a first-order ODE. If it's the second derivative, it's a second-order ODE, and so on. Let's look at a simple example of a first-order ODE. The equation dy dx equals 3x means that the rate of change of y with respect to x is 3x. To solve this, we need to find the function y. Integrating both sides, we get y equals 3 halves x squared plus c, where c is the constant of integration. That's it for today's introduction to ODEs. We've covered what they are, some real-world examples, basic terminology, and even solved a simple equation. In the next episode, we'll explore different methods to solve ODEs. Don't forget to subscribe and hit the bell icon so you won't miss the next episode. If you have any questions, drop them in the comments below. Thanks for watching, and see you next time.